Somewhere deep within my closet rests a beast which hasn't seen the light of day for years upon years. Alright, so here's the story. I'm going back to Norway in just about a week, and a crazy Norwegian fan has prompted me to buy this thing for a ridiculous sum of money. And I'm more than glad to oblige, but in order to be able to do that, we need to give this guy a bit of a once over, because the last time I tried using it, the bias was a bit off, and I'm figuring it's just been sitting for so long that the potentiometers have gotten a bit wonky. So hopefully there's not going to be anything more to it than taking it apart and checking the bias current.
Alright, so I usually connect stuff up to test it beforehand, but in this case, since I know it was acting up and I don't want to risk exploding it, since it's eating 12 brand new, really expensive 8-bit transistors, I'm just going to measure the bias pots. They're 1K pots. This side has the original one, this side has it replaced since I believe it was exploded. But I do believe also both sides were acting up, so there's a 1K pot, which is less than 1K, which is fine. We've got two on the left side pins connected together, so it's just pretty much variable resistor, and that's just measuring just fine. It's set to just under halfway, and it's measuring 400 ohms, so that's pretty much perfect. We should expect similar results on this one, but I'm kind of suspecting that's not going to be the case. So let's see. That's 600 ohms. Curious. It measures just fine. So let's power this thing on and see how much power it draws. Alright, I believe the normal idle power consumption is about 100 watts just above on this thing. That's just out of memory, and I did just check the service manual, and the bias measurement, which you're taking a couple of terminals on the PCB there, is supposed to be 10 millivolts, and we're measuring millivolts DC of a meter there, so let's see, above all, if the breaker is going to handle this, because I believe this is connected to my UPS, so we might get a blackout, but above all, if the power consumption and bias currents are correct. Here we go. 170 watts, 180, yeah, this is considerably higher than it's supposed to be, if I recall correctly. We are having a very low bias current on that channel, so that probably means the right hand channel is very toasty at the moment. Let's measure to confirm. And yes indeed, 160 millivolts, that is way too much bias, so let's turn this toaster off and give the potentiometer a bit of a wiggle to make sure it's not oxidized, and then readjust properly. So we are going to have to take the bias down before we do the initial adjustment, and then we will allow the amplifier to warm up with a reasonable amount of bias on both channels before doing the final 10 millivolts adjustment. So we'll just give this a little bit of a wiggle, making sure to note its rough position. Go from end to end a few times. I'll do the proper way, put some alcohol in there as well. That never hurts. So let's see what our bias has become. A lot better. And our idle power consumption is now 46 watts, which is considerably better. So now I feel comfortable just nudging this while the amplifier is on. And this seems to be tracking quite well, so I don't think we have any problem with like a burnt out potentiometer or anything. We can turn it up and down just fine. So I'm gonna let this sit for like, let's see, is the bias going to rise or fall? Probably fall as temperature rises, yeah. So I'll make it a bit higher than it's supposed to, like 12, 13, and I'm gonna let this stabilize, and I'll be back to do the final adjustment. Alright, quick correction on that, the bias is actually rising as the temperature rises, so I readjusted it to be slightly below 10 millivolts just to give us the best chances at one-shotting it. Well, alright, I noticed while the amplifier was sitting around that it was actually starts to drift a bit of a current on this channel, and if I go ahead and give this potentiometer a bit of a twirl, we'll come across a point. This is going to be gone now just because I saw it earlier. Yeah, it's gone now. But this potentiometer was being rather dicky in a certain spot. It's probably worn down because I've been fiddling with it. But yeah, it's enough for me to want to replace that potentiometer. So I have measured, since the original potentiometer is such a large unit, I was afraid that there would be a rather high voltage and high power associated with it, but if we just measure the voltage across the pot, we will see it's just 1 volt, and it's a 1k pot, so you can pretty much use any potentiometer without running into issues. And I happen to have a couple of brand new ones I purchased for my SX950 Pioneer restoration, which they're the wrong capsule. They're going to be a bit dicky to main, but they're good enough. At least they're going to be brand new and not dicky. These are like rather expensive Bourne's pots, which performed excellent in the Pioneer. So I'm going to dismount this channel and just put a new pot in there, just so that I don't sell a faulty unit. I also noticed that one of the bulbs had burnt out, so I've ordered a set of new bulbs from Germany. Here's to hoping they arrive before I have to get going with this thing. Fingers crossed. So, this procedure, thankfully, I think I can cheat a bit. Normally to solder anything, you'd of course have to dismount the whole amplifier module, then take out the PCB, which requires redoing a bunch of soldered on connectors. But for the bias pot, I can actually very easily squeeze my soldering iron in there. So I'm thinking I'm just gonna use solder braid to suck the solder off, and then reinstall the potentiometer without taking anything apart at all. And the access is so good, you can see I can easily move a soldering iron around there, but I think it's going to be a decent quality repair. We'll just get some flux down in there, and some of a braid, just good measure. Let's get this pot out of there. There we go, all loose. Out she comes. So it seems that my choice in bias pot for the original repair of this thing wasn't particularly good. This is a cheap potentiometer, so let's see if we can just figure out what's gone wrong in there. Perhaps it's gotten burnt or wonky in some other way. There she comes. And how does she look? Well, that actually looks pretty okay to me. No obvious signs of issues at all, so it just has to be the fact that it's a rather cheap potentiometer with a copper spring which is just oxidized over time, because that's, yeah, I'd rather see that gold plated as it assuredly isn't the more expensive potentiometer. That's probably what happened. This got oxidized and caused a bad connection. So the new pot actually fits rather well with its original pinout. If you just stick it on like so, but that would make adjustment almost impossible due to the aluminium plate there. So I'm going to try and fit it at a bit of an angle like so, to get it to face upwards a bit, enabling bias adjustment. such a luxurious feature. There we go, all 3 pins protruding, and while you can't see it, the potentiometer is at an angle which allows for adjustment, so I'm just gonna solder that in and we'll be good to go. Alright, so after meticulously mounting, cleaning and finalising that potentiometer, I went on to test measure it in order to preset the bias to a reasonable level by adjusting the pot to about 400 ohms, and I realised that I'd made it a 100 ohm pot instead of a 1k one. So I've now entirely replaced that. We're using a 1k 10 turn pot because that's the best thing I've got. At least we'll be able to very accurately set the bias now. So with this pot I actually managed to trim it into about 400 ohms as intended, and we should have a reasonably sane bias now. It shouldn't be zero, it shouldn't be output smokingly too high, so let's give it a go. Flick the switch and see what happens. And that's quite spot on, 7.5 millivolts across the test terminals, and we should be able to adjust that as well. Yes indeed. Perfect, so now to let this properly settle and adjust it with a working new pot. Alright, I've now left the amplifier sit for pretty much the entire day. It is many hours later, and the bias on both channels has stabilized to something very close to 10 millivolts. So I'm quite happy with that. The only minor complaint I can really see while messing around is we've got a 23.5 millivolt DC offset on one of the channels, below 10 on the other, but that's well within spec. I believe it's specified to below 100 millivolts. So that's it. The bias pot is fixed. The amplifier should now be performing well, so I've powered off the distortion meter and I'm going to give it a quick 1 kHz test just to confirm that we don't have any weird distortion going on, and then I'm ready to ship it out. Alright, so I've rigged up a tester. We're doing 10 times 100 Hz, 1 kHz at my reference level of 0.775 volts. We're currently measuring the input level, so let's just start turning off the volume. We'll be using the attenuator on the power amplifier. I'm going to do 1 channel at a time since my load cannot handle both. And we'll just do a couple of checks. Let's start with 1 watt, which is about 2.83 volts out. That's close enough, and our distortion is rather low, 0.023%, which is a very good result for an amplifier in this power range. Very good indeed, actually. So let's do 10 watts, about 10 volts. That's about 10 volts. And we've got less than 0.03% distortion, a bit lower, 0.016 thereabout. Looking good. So let's do like 50 watts or 20 volts. Yeah, that's somewhere around 50 volts, 50 watts. And we've dropped down to 0.005% distortion, and I think we're gonna have to raise the input signal a bit to get to the rated power. Let's do like 100 watts, and that should be about 100 watts. 28 volts. Yeah, less than point. Wow. So at 100 watts into 8 ohms, we have got. Is that even correct? Yeah, that is a correct measurement. We have got 0.0013% distortion. That is a rather impressive result, I must say. So now I'm just gonna have to turn the volume up on the signal generator a bit, because you need more than 0.775 to get this up to its rated power output of 240 watts per channel. And that is 43.8 volts out. We'll put a range to 100 volts full scale, attenuator at maximum, and just to turn it up until we get to 43. That's 43. Distortion is 0.0024%, which is very, very good. Let's see, when we start clipping at, let's say, more than 1%. There we go. That's clipping at 47.5 volts, which equals about 280 watts or so with one channel driven. So I'd say that's a very good result as far as power is concerned on that channel. Let's check the noise floor and we will be done. So I'll just turn the signal gen off, attenuator at minimum, measure the noise at there, and we have got very little noise indeed. That's going to be minus 80, minus 70, about minus 78 decibel volts on that channel, which is quite good. That's perfectly acceptable for an amplifier, well, very good for an amplifier this size. I do believe this thing has a bit of an issue with picking up mains hum though. If we turn it up, the attenuator up, we do pick up some mains hum coupling from the transformer. We can see that because if I enable the 400 Hz high pass, which takes away all the 50 Hz hum, we get a very much improved noise figure. But all in all, the actual power amplifier module is working absolutely perfectly. That's a layout issue with this particular model. So, right channel gets a perfect pass on all accounts. Let's check the left channel and we'll be on our way. Alright, left channel, let's do the same test. So we've got the exact same setup, 0.775 volts reference, and we will test for distortion at 1 watt output, which is 2.83 volts. That's close enough. And we have got 0.0135%, which is absolutely within spec. Let's do 10 watts equaling to about 10-ish volts out. 10 volts full scale, that's close enough to 10 watts. We have got about 0.009% distortion, perfect result. Let's just do whatever maximum there is. That is like 100 watts-ish. And we have got 0.002% distortion, absolutely perfect, orders of magnitude within spec. So let's adjust for maximum power output, 240 watts per channel, which is about, what was it, 43 volts? 240, 43.82 volts, so almost 44. That's with 2 channels driven, so with 1 channel driven, we can just go for spot on 44 and it's gonna perform within spec, I promise you. And indeed we have got 0.00235%, absolutely perfect. Let's turn it up until it clips at 1%, which is probably going to be about the same as the up channel. There we go, clipping at 1%. At 48 volts, which is about 280, 290-ish watts. Absolutely perfect result. Check the noise level, turn the signal gen off, all the way off. We will measure the input level at idle, and we have got minus 78 dB volts. absolutely good results. Probably have the same issue with 50Hz pickup if we enable the low pass filter there. It's performing, the left channel is performing a bit better, has a bit less 50Hz pickup, but all in all, it has a bit of a 50Hz pickup issue. No biggie, the amplifier module itself is working just fine. Again, that is an issue with how the wires are rated around this giant big transformer in here. It's hard to avoid some EMI. But all in all, good result. This amplifier is good to go. I'm happy to call this according to the old performance report I did on it like about a year ago, perhaps when I was fixing some other issue on it. What relief. P2200, living again, and it's soon gonna be leaving my shop for good. And there she sits, ready to take on new challenges in a foreign land. I can't say I'm not a bit saddened to see this one go. After all, it is the first real project which brought any kind of significant views to this channel. Back in 2013, shot with a compact camera. But alas, I do admit to not giving her the love she has longed for and deserved for all these years. And I do know that the new owner is going to provide that. So I'll have to say, thank you for watching. Cheerio.